Before we get started with today's repair, I just want to give a shout out to one of my good friends, Jason, at Engineering Scale Models on YouTube. Engineering Scale Models is doing quite a lot to help me and a few of the other community members to build a pretty detailed diagram of the Nintendo Switch. So if you could head over to his channel, there'll be a link down in the description down below, and show him some love by subscribing and watching a few of his videos. That would really mean a lot to both himself and to me as well. The link will be in the description, but I just want to thank everyone in advance for showing him some support. And let's get him to 1,000 subscribers before the end of the year. Right, hello there ladies and gents, welcome to another repair video. Today we're going to be taking a look at this Nintendo Switch which has been sent in, and this particular console has no power. So the ticket that was sent with this says port replaced but no power. So it originally went to the company in London who sends me these consoles, or most of the consoles, and they changed the port and it still has no power. So he sent it over to me to take a look at and see if I can get it fixed. So first thing I'm noticing straight away is that we are one screw missing here. We're missing another screw just here. And that looks to be about it. Yep, so we got the screw there. Got an SD card there that has to come out before we can take this thing apart. So I'll pop that into a little compartment just to keep it safe. So that can go in there. What I'm going to do first of all is what I always do, and that is going to be to plug this in to a power source using the USB ammeter. So what this is going to do is tell me whether it's detecting the charger or not, and give me a general idea of what's happening with the console. Okay, so we get 15 volts at 0.15 amps. Now, what usually happens is when the port is damaged, it sometimes has a knock-on effect, something what we call collateral damage, where it will damage one of the main three power chips on the board, and they are either the M92T36, which is the main power management IC, the P13 USB, which is the USB-C HDMI controller, and it also handles some of the USB-C input as well, and also the BQ24193. Now, we can kind of determine sort of what's happening based on how much current is being drawn, and in this case, like I said, that is 0.15 amps, so 150 milliamps, and when we are running at 5 volts, we usually get around about 0.7 amps, between 0.5 and 0.8 usually if M92 has failed. Because we're at 15 volts and we're at 0.15 amps, that's telling me that there's probably an issue with M92. So we're going to take it apart and take a look and see if we can figure out what's going on. Right, okay, so taking a look at the board then, the first area that I'm going to be focusing on, just given the symptoms, is going to be this area here, which is where M92T36 is. So when we take a look on the board, we can see we've got the CPU shield here, and then if we go over to the right where the battery meets the board and then go up to the top, you can see we've got M92T36. So this is the main power management IC for the Nintendo Switch, and it's a 40-pin QFN. And this controls all power going into the board. So what I'm going to do is I'm going to get the multimeter, and I'm going to check for shorts around this particular chip, because this is one of the most common failure points, and given the symptoms drawing 150 milliamps or 0.15 amps, I'm going to say that this is going to be the first place we should be looking. So I'm going to pop the multimeter into continuity mode. Continuity mode is a mode that beeps when we complete the circuit, and I'm going to pop one probe on ground. In this case I'm going to use the shield, so you can see there I've got one probe on the shield, and then I'm just going to check the capacitors around the M92T36 chip. No shorts, no short. So these two caps here, we need to check the bottom one, and we need to check the bottom one here. And there's no shorts. This one is ground. This one is ground. Okay, so let's check this cap at the bottom. Good. And then let's check these two caps here. And this cap here is shorted to ground. So this cap here isn't actually linked to M92T36. It's linked to P13 USB, which is on the back of the board. But before we flip the board over, I'm going to check, first of all, make sure that the fuse is good, although it should be. And that's fine. Next, because this coil always trolls me, I'm going to check that. And that coil is fine. And this is quite interesting. What's this on here? I think that's just a little bit of gunk that's built up from the last job. Not quite sure how it got onto BQ24193. So BQ24193 is the battery management IC, and this controls power for charging and also allows power through the battery as well. So let's check for shorts on this before we flip the board around. So one probe on ground again, and I'm going to check this side of the cap, and that's fine. This side of the cap, that's fine. This side is fine. And this one, and this one. Let's check these resistors also. Fine. And all of that appears to be fine, so there's no shorts where there shouldn't be. So I'm happy that the BQ is absolutely fine. So let's flip the board over then, and let's take a look at P13 USB, which is this chip here. So this little rectangle chip is P13 USB. It's the HDMI and USB-C IC for the Nintendo Switch. This commonly goes when that capacitor is bad on the other side, that tested bad. So let's check for shorts. And we get a short on this side as well. So I'm going to say most likely that the P13 is bad. But what I'm going to do first is just check these EMI filters here. These are essentially just coils of wire, and these filter out electromagnetic interference. And we should have continuity from the top to the bottom on each one. We shouldn't have a short between the two filters. So you can see that we've got 4 pins here. The top and the bottom is one filter, the top and the bottom is one filter, but they shouldn't have continuity across each other. So let's just check for continuity on all of these. And that one appears to be bad. So we are going to have to change one filter. Okay, let me just double confirm number 2. So we get continuity that side, but we don't get continuity this side. So there's one filter bad, and it looks like P13 is bad as well. So what I'm going to do is I'm going to get this removed and then I'll see if the short is cleared. It should be, but we'll double check once we've removed the filter, or the chip rather. So I've got my hot air set to 420 degrees and my airflow is set to 50%. There we go. And now let's check for a short to ground again. And short is gone. So that side is ground, that side is not. And there you go. So you can see the short has gone now. So P13 is 100% bad. So let's get P13 changed, but at the same time I want to remove this filter and replace this filter as well. Okay, so one bad filter removed. So what I want to do now is just clear up these pads, replace all of the solder with leaded solder, and then I can get the components replaced that need replacing. So let's just add some flux to the area. And then I'm going to take some leaded solder. Okay, so let's get this leaded solder replaced then. Okay, that's good enough. Okay. We've got a little bridge there that I didn't notice, so let's just fix that. There we go. Okay. Right, let's clean this up and we can have a look at those pads. So to clean it up, I'm just going to use some isopropyl alcohol and a cotton swab. And that little bit of excess solder on the middle pad is absolutely fine. Awesome. Okay, so I'm going to get a new P13 chip then. These are fairly cheap online. You can usually buy them for around about £1.50 to £2 each, or around about $3 US, depending where you buy them from. I generally buy mine from AliExpress because they're generally cheaper. And if we take a look at P13, we'll see that it's actually the wrong way around. So pin number 1 is top right. So we're going to flip that around. And then I'm going to flow this into place, and then I'll add some flux afterwards. And then I'm going to press down on the chip. and just let the excess solder squeeze out. Okay. Okay, that should be fine. Good. So now I'll flow that back into place once more. And I seem to have knocked a capacitor there. That weren't meant to happen. Okay. Right. So now let's get a new filter on. Okay, let's add a little bit more flux. There we go. Good. Okay, let's give this a clean. Using some IPA and a toothbrush. And I'm going to flip it around and give the other side of the board a clean as well. Just around by the battery management IC and the charging port. I did notice a bit of flux on the board from the last repair attempt. Okie doke. Right, so let's inspect this on an angle then. It's a little bit tricky to get it into focus, but they do all seem to be lined up nicely. Seems to be getting a connection on all pins. So let's give this a test then, shall we? So let's just finish cleaning. Okay. Now what I'm going to do is just test that one cap again, make sure that we don't have a short anymore. So multimeter back into continuity mode then. And as you can see, no short on the top of that cap anymore. Excellent. Right, so let's get this tested then, shall we? Okay, so what I'm going to do then to test, first of all, before I do anything else, is just pop in the battery and then pop in a charger and just see what happens when we try and charge it. Okay, so the switch charger that I was just using, the 15 volt one, I actually borrowed off someone and they've just asked me for it back about 10 minutes ago, so unfortunately I'm not going to be able to get 15 volts now, but I can use this power bank I've got here and get 12 volts. So let's just plug this in and see what happens. So it's on 5 volts right now, as you can see. Zero point zero 0.01, 0.25, 0.26, and that's charging. So 0.26 amps is typical slow charge current for a Nintendo Switch with no LCD and backlight plugged in. So what I'm going to do then is I'm going to just plug everything in, enough for testing, and fingers crossed this is now going to work. So I'll just get the main components plugged in, such as the LCD, the backlight, the touchscreen and the battery. We don't need anything apart from that, not for the initial test. So I'm going to just loosen off the fan there, just so I can actually fit the board back in, and that's just completely snapped. I can glue that afterwards. It was already broken, so that's kind of not my fault. Never mind, I can glue that afterwards and sort that. Okay, so that should be loose enough now to drop the board in. Nope. Okay. There we go. I just need to route the cables properly so as I can get everything in. Just like that. And then I can start popping in the ribbon cables. And let's pop the fan in for good measure. There we go. Let's pop in the backlight. We may as well pop everything in, to be honest. I've got a good feeling about this one now, in that it's probably going to work. Screw down that fan. And let's get the touch screen. And what I'm going to do is I'm actually going to screw in one phillips screw. The reason for that is because this screw is hidden when the touch screen's in, and I like to avoid as much as I can the disassembly and reassembly of the actual switch, especially because of the touch screen, because it's a little bit more awkward of a ribbon to get in. There's a bit more chance of breaking it, so I will screw a bit of that down. I don't want to damage the console. And I'm also going to take another 2 silver screws and screw down the USB port for security as well. I don't want to be damaging the port. Okay, that should be enough for testing. Let's plug the battery in. Just flip it around. And let's take the amp meter. And I think my battery's just died on the amp meter. And there we go, charging symbol. So that is now charging, so I'm going to leave this to charge, and fingers crossed it should be working. The battery is actually full, so it just turned itself off. Never mind. So I'm going to leave this to charge. It's going to take about 20 minutes or so to charge. It's not quite slow charging yet, it's trickle charging at 5 volts. So it might ramp up a little bit later on, I'm not sure, it depends on the power bank. But it's on 0.34 amps at the minute. We need to get that up to 0.46 amps at 5 volts for it to start fast charging. So we'll see what happens. I'm going to leave this for about 20 minutes to half an hour to hopefully charge up to full capacity. Or rather, not full capacity, but enough capacity to turn the console on. So I'll leave it with this and I'll be back in a little while. Right, okay then, so it's been about half an hour now, and it's actually been that long that I've actually managed to edit the first part of the video. So it's almost ready to upload, which actually I kind of like doing it that way. So this is now fast charging. It's still on 5 volts, well 4.82 with the voltage drops and things, but it's now fast charging at 1.43 amps and the switch has actually turned on. So as you can see there, we're on 10%. The battery was completely and utterly drained, which I kind of expected. Ignore all of that gunk around there, that's just a bit of flux. It will get cleaned before I actually go ahead and send it back. So touchscreen appears to be working, which is great. And let's test the other side of the charging port. And yes indeed, we are charging. That's great news. So what I'm going to do now, while the battery's still got some charge, I'm going to test it on the dock. So I'm going to use my mini dock. I'll test it on the bigger dock when I can get another 15 volt charger. But I'm going to test it on the mini dock for now and just see what happens when I plug it in. So we're drawing 0.02 amps without it plugged on. And let's take a HDMI. So it's charging. Drawing 1.2 amps. And the screen's just gone off, which means that it's probably docking. So I'm going to load up the camera app on my computer. And as you can see, that is docking absolutely fine. So I'm going to go and grab some joycons really quickly, and then we can test this with joycons as well. Right, okay, so now that I know it's docking, I can take some joycons. These are my brand new joycons, which I use for testing consoles. So you should have some charge in them. And I didn't connect that Joy-Con rail. Okay, well, I'll test that one in a minute. Let's just test this one. That rail doesn't feel good. That rail doesn't feel good at all. It does go in, and it does connect. And back. Controllers. Let's see if it's going to charge the controller. The fan is spinning, so it should charge the controllers as well. And there we go. So that's charging the controllers as well. Good. So if it wasn't charging the controllers, then we would have to change the little MOSFET above M92, but that seems to be working fine. So what I'm going to do then, I'm going to shut it down. And there we go. So let's shut it down. And what I'll do is I'll reassemble it now, because I know that one Joy-Con is working. So or actually, let's just connect the Joy-Con up first. I don't want to have to take this back apart again afterwards. So let's connect up this one Joy-Con before we go any further. And let's get that one tested as well. Okay. So let me check the left Joy-Con now then, really quickly. And then I can continue reassembling. And it might help if I connect up the battery. And it comes up paired. So that appears to be working. Let's check wireless Joy-Cons. That one works. Let's check this one as wireless, and now it's reading 17% for some reason. Very strange. So that Joy-Con rail could definitely use some work, but I'll leave that to London, the company that sends these to me. I'll leave that for him if he wants to change it or not. I'll ask him before I send them back. These are going to be a couple of days before they go back anyway, so I'll ask him, and if it needs it then I'll change it, but for now I'll leave it as it is. Let's check Wi-Fi. Let's make sure that we can connect to the internet. And it does pick up the workshop. Good. Excellent. Okay. Cool. So we get internet as well. And that's updated the time. So according to this, everything appears to be working as it should. So I'm happy with that. So all that's left to do now is just to get it put back together. This will be charged until it reaches 100%, and then it will be turned off and left off. And then basically all that's left to do then is just to confirm whether or not the Joy-Con is going to be replaced. That will be decided by Console Repair London, the company that sends me these. And then if you want it replaced, I'll replace it, or if not, then I'll just leave it as it is. So just pop some fresh thermal paste on there. This is going to be brand new MX4 thermal paste, so that's unfortunate because it's going to be wasted. I know it's going to be MX4 because the company uses the same thermal paste as me, and that is absolutely 100% fresh. So bit of a shame to waste that, but we can't leave it on there. We always have to change the thermal paste when we take the heatsink off. That's why I don't do this until the last second. So let's get that on there just so as it doesn't overheat. Beautiful. Okay, so I'm going to carry on reassembling this then, and I'll fast forward through this process. Okay, and that is all she wrote. So as you can see, it's detected the micro SD card. So we're going to press later, and then I'm going to just quickly test a test game in the game card slot. Game card could not be read. There we go. Okay, I'll definitely need to clean this game with some IPA, but that is reading the game absolutely fine. Data management, always delete the software that you install. Just like that. Okay, and that is pretty much that. So this console is pretty much fully working. One thing I do want to check is these Joy-Cons again, because I did notice that the side screws were a little bit loose, and nope, that is still fairly tight in there. Whether or not that's going to be an issue for the customer, I don't know. I will find out. Unfortunately, I don't have any spare screws, so that's how it should feel. It should be nice and smooth, especially considering these are brand new controllers. I've only used these once, but that is really stiff. Whoops, it's that stiff I just dropped it. So yeah, whether or not that's going to be an issue, I won't know until I actually contact the company in London. But I'll find that out in the morning. It's you know, it's 8:10 at night now, so as you can see from the time there, this is the last job of the night. So let's just summarise then. This console was originally sent in for a Type-C port replacement, and that was performed by the London company who sends me these consoles, so Console Repair London. And after he'd changed the port, he's noticed that it's still not charging, so he sent it down to me, and I've determined that, well, I thought it was the M92 because it was drawing 0.15 milliamps, 0.15 amps, 150 milliamps, but on further inspection I've determined that the issue was actually related to the P13 USB and one of the EMI filters. But by replacing those two components, which essentially is probably a £5 repair, we've managed to get this console working again, and whoever owns this is going to be super happy. So that's going to be it for this video. Thank you very much for watching. If you have any comments or questions, leave them down in the comment section down below. I'll do my best to answer them. If you want to see more repair videos where I repair mainly consoles, but occasionally other things too, be sure to hit the subscribe button and turn on the bell notifications so that you're notified every time that I upload. I also now have channel members where I'm going to be posting all videos from next week 2 days early for members. So if you do want to support the channel, be sure to hit that join button down below, and you can support the channel from just £2 or $3 per month. But that's going to be for this video. Thank you ever so much for watching, and until next time, see you later. Bye for now.